Hello.
Yes, ma'am.
Very good. So now I'll continue if you have that material, I will continue that one. I will share that screen. Just wait. Okay. So next question we'll discuss. A sample of size 400 are drawn and the sample mean was found to be 99. That is sample mean. Test whether this sample would have come from the normal population with mean 100 and variance 64 at 5% level of significance. So now we have to test this one. Okay. So sample size it is given 400. Okay. So that means small n is equal to 400 and the sample mean also given. That is your 99. Sample mean means x bar. So n is equal to 400 which is greater than 30. That means large sample we have to apply. Then x bar is equal to 99. That means sample mean and population mean also given to you. That is 64. Sorry, the population mean is given 100. Okay, and variance, population variance given 64. So population mean means you know mu. That is your population mean and variance that is sigma square, not sigma. Okay, standard deviation means it is the square root of variance that is root over of 64 that is 8. Okay, so so sigma equal to 8 we have got, mu equal to 100, x bar equal to 99, n equal to 400 that is your sample size. Now what we have to test? Already I have told it is a large sample test means large sample test means Z test for single mean because only single population it is given, variety of population. That's why the null hypothesis it will be the definite statement about the population parameter that is your mu. So mu is equal to 100 or not we have to check. Okay. So if mu is equal to 100 that is your null hypothesis, then alternative hypothesis H1 that is your mu not equal to 100 that is your alternative hypothesis. So not equal to means 2 tell test. That's why within bracket it is written 2 tell. Next it is coming alpha percent level of significance. Already it is given in the question that 5%. So if it is not mentioned in the question that level of significance, you can take either 5% or 1%, whatever it may be. Then next will come to test statistic. Test statistic, the formula you know that Z test is equal to x bar minus mu divided by sigma by root over of n. Okay, x bar minus mu divided by sigma by root over of n. So x bar is equal to 99 minus 100 divided by 8. Just you put the value and get the answer directly, and we have got minus 2.5. But we have already told, I have already told that whatever the calculated value, always you have to take the absolute value. That means modulus. So Z modulus is equal to 2.5 now. Means minus 2.5 modulus or absolute value is 2.5. So this is your calculated value. Then critical value or tabulated value. Any statistics book you can find that critical value or in Google also you search that critical value or tabulated value of Z at 5%, 1% and 10%. Two tell test and right tell test or left tell test tabulated value it must be given and you have to remember that one. So two tell test here it is your two tell test and 5% level of significance Z tabulated value or critical value is given by 1.96. So 1.96 and the calculated value is 2.5. So 2.5 is greater than 1.96. So we may reject the null hypothesis. That means whatever the null hypothesis we have taken that mu is equal to the value what we have taken, just to check, I think 100. No, mu is equal to 100. It is rejected. It may be rejected. You cannot write in the conclusion it is rejected. Always you write it may be rejected. So here I have written the conclusion. So comparison it is over. Since the calculated value is greater than that critical value, we have to write in the conclusion the value of Z at 5% significant level of significance. We may reject the null hypothesis. We may reject, always you write we may because it is not 100% true. With statistical results, we are only calculating that one through statistical test. That's why you have to write we may reject the null hypothesis at 5% level of significance. Hence, there is a significant difference under null hypothesis. That means whatever the null hypothesis we have taken, that mu is equal to 100, it is not equal. There is a significant difference, means they are not equal. So the sample has not drawn from the normal population. So the hypothesis we have taken, the sample has drawn from the normal population, it is not true. Okay. Similarly, at 1% also it is tested. The same answer it is written. Okay. So next we'll come to another question. A sample of 400 students is found to have mean height 171.38 centimeter. Can it be reasonably regarded as a sample from a large population with mean height 171.17 centimeter and standard deviation 3.30? Okay, this is your one question and you have to solve it. That I think you can solve it, because mean height sample size it is given 400. This is the task for you and I think you can do it. Okay, so sample size it is given 400, which is greater than 30, means the normal Z test you have to apply. And sample mean also X bar it is given 171.38 centimeter height, mean height of the student. Of how many students? Or 400 students. And population mean height it is given. We have assumed that the entire population, entire students mean height, entire population, the students in the population mean height is 171.717. Whether this statement is true or not, now we have to test. And population standard deviation means sigma, it is given 3.30 centimeter. I think you can do it. This problem you have to do by yourself. Okay, the next question. Next question, it is given in the form of data. That question number 3. Okay, question number 3. A random sample of size 100 from a large population give the following distribution. Here X and frequency it is given, means data set it is given. Sample size data, sample data it is given to you 10 to 20, 20 to 30, 30 to 40, up to 50 to 60, and frequency it is given 13, 20, 45, 13, 9, like that. So now what you have to do? Test the hypothesis that this sample comes from normal population with mean mu and mean 40 and standard deviation 10. That means population mean it has given to you, that is your what? 40. Population standard deviation it is also given to you, that is 10. So by using this we have to solve the problem. So now the first question, first it is solved. N is equal to 400. First question, X bar is equal to 171.38 centimeter, mu is equal to 171.17 centimeter, sigma it is given 3.3. So null hypothesis, whatever the mu it is given, always you have to take for population, the population information, population parameter, the value, whatever it is given related to mean, you have to write in your null hypothesis. That means mu is equal to 171.17. That is your null hypothesis. And alternative hypothesis not equal to, then level of significance, that is your 5% level of significance. So test statistic, already it is given that Z is equal to X bar minus mu sigma by root over of n, that is the formula. Now you put in the formula. Okay, the value just you put, you'll get the result that 1.272. Okay, so Z calculated value is 1.272. Z tabulated value at 5% level of significance, it is 1.96. Then now we have to compare. Compare means Z calculated value is less than Z tabulated value, that is your 1.965% level of significance with two tail test. So what we have to do? That we may accept the null hypothesis. That means since the calculated value of Z is less than the tabulated value of Z at 5% level of significance, we may accept the null hypothesis at 5% level of significance. Hence, there is no significant difference. If it is rejected, there is a significant difference. If it is accepted, there is no significant difference under null hypothesis. So the average height of students in population is 171.17 centimeter. It is true. So whatever we have taken the assumption that population mean height of the students is 171.17 centimeter, it is true by doing this testing of hypothesis. Okay, I think all of you are clear this problem. Hello, all of you are clear?
Yes, ma'am. Hello.
Yes. Okay. Then second.
Hello.
Yes.
Ma'am, I have one doubt. 1.96.
Yes.
Where is come?
Where you are getting?
Yes, 1.96 जो data है.
No, actually that is the tabulated value. Any statistics book you find the critical value of Z at 5% level of significance with 2 tail test, in 1 tail test. In the any statistics book it is there, or in the Google also you search that critical value or tabulated value. If it will come in the exam, they will provide you the tabulated value. Okay.
Okay.
That is tabulated value. You cannot calculate that one. Only you have to calculate the value, that is your calculated value, x bar minus mu divided by sigma by root over of n. That formula, after using that formula, you will get the result, that is your calculated value. But the tabulated value, if it will come in the exam, this type of problem, then they should provide you the tabulated value. Okay. At 5% level of significance, the tabulated value is different. At 1% level of significance, the tabulated value of what? Z. With 2 tail test, with right tail test, with left tail test, different it is there. So they must provide the tabulated value if it will come in the exam, or in the Google also you can get that one. Okay, any statistics book you follow, you can find also. The next question, it is crossed. I think somewhere it may be wrong. Next we will solve that one. Third question. Okay, third question, what it is given? N is equal to sample size, it is given. Okay, x bar we have to calculate because the data it was given only, and mu also directly given. Population mean 40, population standard deviation given 10. Third question. So for x bar we have data given. Okay, data it is given to you. That means so what it is given? Data only. That is 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. Then frequency it is given 13, 20, 45, 13, 9. Then now just you check. I think all of you have known that how to calculate the mean from the continuous data. This is your continuous data. First you have to get the mid value. That is L1 plus L2 by 2, 10 plus 20 by 2, 20 plus 30 by 2, 25. Like that way mid value you'll get. Then you have to calculate the assume mean. Assume mean from which value? From M only, mid value. So how to get that assume mean? Assume mean, that is your lowest value plus highest value by 2. Then you have to take the approximate value from the mean. So lowest value from M is 15, highest value from M is 55. So it will be 70 by 2, that is 35. 35 it is available in mid value. That's why directly you can take the assume mean as 35. If it is not there, also approximate value you can take. It may be less or it may be more from the mid value. So by using that mid value, you can find out that M minus A, that is 15 minus 35, 25 minus 35, like that. Then 15 minus A by H. H is your class interval. So what is the class interval or gap? That is your 10. So minus 20 by 10 minus 2, minus 10 by 10 minus 1, like that way you get minus 2, minus 1, 0, 1, 2. That is your D dash. Next you have to find out FD dash. FD dash means frequency into D dash, you multiply, you get FD dash, and the summation also you get. So what is the formula for x bar? A plus, this is the step deviation formula for mean of continuous data. So x bar is equal to A plus summation FD dash by N into H. So like that way you get x bar is equal to 33.5. So what is your null hypothesis here? The population parametric value, that is your mean. Mu is equal to given to you 40. That is your null hypothesis. Always the statement you have to write in the null hypothesis that must be related to population only. You don't write anything related to sample, because you have to go for finding the result for population only through testing of sample. Testing sample को करिकी तमे population रे result बाहर करिवो ना, तो population finally आमे conclusion draw करछु population पाइंदा. That's why you have to write a null hypothesis for the population parameter. So population parameter, what it is given, mu is equal to 40, it is given. That's why mu is equal to 40 you have to take. So then alternative hypothesis obviously not equal to. Then it is level of significance, that is your alpha percent, 5% level of significance. So the formula already you know, x bar minus mu by sigma by root over of n. By using that formula, you get Z calculated value is equal to minus 6.5. So it will be obviously 6.5 because you have to take the absolute value or what? Modulus. So 6.5, that is your calculated value. Then tabulated value already you know, 1.96, 5% level of significance to tell test. So but here you are getting calculated value is greater than the tabulated value. Wrongly it is written less than. Please you correct it. The student who has written it wrongly, she has written that 6.5 is less than 1.6. Here you have to change it. 6.5 is greater than 1.96. That means we may reject the null hypothesis. We may reject the null hypothesis means a conclusion it is correct, but the symbol there it is wrongly means written. Just please you correct it by yourself. So since the calculated value is greater than the tabulated value at 5% level of significance, the most important thing for this testing of hypothesis problem is that how to set up the null hypothesis and how to write the conclusion. That is most important. If you will not write the conclusion and only up to the comparison you stop it, you will lose minimum 2-3 marks. If it will be 5 marks or 10 marks question, minimum 3 marks you will lose, because conclusion is the most important one, whether you reject or accept the null hypothesis. So for this particular problem, the calculated value of Z is greater than the tabulated value at 5% level of significance. So we may reject the null hypothesis, and it means there is a significant difference under null hypothesis and the population mean may not be 40. That means we are rejecting that one, but we have taken that mean is equal to population mean is equal to 40, which is not correct. Means it may not be 40. Okay. Then next will come to large sample test for 2 means. So all the problems we have solved for single mean. Next will come to large sample test for 2 means. So already I have given the example that suppose you will take that Sambalpur University and Utkal University, the total number of students, height or weight we will compare whether Sambalpur University students average height is equal to the Utkal University students average height is equal or not. That we have to test. That in that case, what will do? Yes, Sambalpur University and Utkal University both will, if you take, then in that case it will be coming under large sample test for 2 means. So large sample test for 2 means 2 different population, you have to draw 2 different samples. Okay. So here you have to test whether the sample is drawn from the same population or not. That means the mean height of Utkal University and mean height of the Sambalpur University, whether it is equal or not, that we have to check. That's why it will be mu1 equal to mu2. For Sambalpur University, suppose it is mu1, for Utkal University it is mu2, and we have to take the assumption that whether the average population mean is equal to the population mean of Sambalpur University is equal to population mean of Utkal University or not. Okay. Then next one, it is not equal to alpha percent, it may be 5% or it may be 1%, the same, but the formula it is different. In that case, x bar minus mu divided by root over of sigma by n, but here x1 bar because population 1 and population 2. Similarly, sample 1 and sample 2. Sample mean for Sambalpur University it is x1 bar. Sample mean for Utkal University it is x2 bar. Similarly, population standard deviation sigma 1, population standard deviation for 2 it is sigma 2, n1, n2. N1 means sample size. For Utkal University it is n2. Sample size for Sambalpur University it is n1. So this is the formula for testing it, that z is equal to x1 bar minus x2 bar divided by sigma 1 square by n1 plus sigma 2 square by n2 root over. So like this way you have to solve the problem related to this z test for 2 means. So here one important note, In case of large sample test 2 means if the population standard deviation are unknown. Suppose population standard deviation sigma 1 and sigma 2 are unknown. Instead of that, you can use S1 and S2. Okay. So what is your S1, S2? The suppose sigma 1, sigma 2 it is not given. S1, S2 you can use that one, sample standard deviation. So what is your S1, S2? That is your sample standard deviation. All the notations here it is given that mu1 first population mean, mu2 second population mean, n1 first population size, capital N2, capital means population. That is your second population size. Sigma 1 first population standard deviation, sigma 2 second population standard deviation. Similarly, x1 bar first sample mean, x2 bar second sample mean, n1 first sample size, n2 second sample size, S1 first sample standard deviation, S2 second sample standard deviation. Everything it is written to you, and how to calculate and what is the formula also it is mentioned here. Mu1 that is your population mean summation capital X by N1. Similarly, mu2 summation Y is divided by N2 capital N2. Similarly, sigma 1 summation X minus X bar by N1 root over summation Y minus Y bar by root over square by root over, that is the standard deviation. Similarly, sample mean for population 1 summation X by N1 summation Y by N2. Similarly, S1 and S2. So by using this one, the problem it is solved. I think this problem please read by one, means read by yourself, then we'll discuss. This is the example related to the test for 2 means. In order to make a survey buying habits, 2 markets A and B has chosen at 2 parts of city 400 women suppose are chosen at random in the market A, and their average daily expenditure on food is found to be 250 rupees. Okay, with a standard deviation 40 rupees. And the figures 220 and 55 respectively in market B. Suppose there are 2 market A and market B. Okay. So 400 you have taken for A market, 400 shopkeepers, for 400 customers for market women shoppers from market A and 400 for market B. And these are the data it is given to you. So what you have to study? You have to study where test 1% level of significance, whether the average daily food expenditure of the 2 population of 2 population means 2 markets A and B of shopping are equal or not. That we have to test. So N1 it is given 400 for sample size market A, N2 sample size of market B 400 it is also given. X1 bar sample mean of market A 250, X2 bar sample mean of market B 220, then sample standard deviation of market A it is 40, sample standard deviation of market B it is 55. Null hypothesis it is given mu1 equal to mu2, that we have to test. Always this is the two population, no, that's why mu1 equal to mu2, and alternative not equal to level of significance 1%. Formula we know, x1 bar minus x2 bar root over of s1 square by plus s2 square by n1 plus s2 square by n2. So now n1 n2 you know, s1 square s2 square means population standard deviation it is not given, directly sample given, that's why you can take s1 square and s2 square. So since it is a large sample, so instead of sigma 1 sigma 2 if it is not given, you can take the sample data also, sample standard deviation you can use. Okay, that is the most important point you have to write in the exam also. So next, the calculated value we have got 8.82. So what is your calculated value? Modulus of calculated value same 8.82. Then critical value of 1% level of significance or tabulated value of Z at 1% level of significance it is 2.58, but 5% it is 1.96. Mone rakhithibo total test re. Total test 5% Z value is 1.96. Total test 1% level of significance Z tabulated value is 2.58. So here Z calculated value is greater than the tabulated value as a tabulated value. That means we may reject the null hypothesis. The same type conclusion you have to write here. Since the calculated value of Z is greater than the tabulated value of Z at 1% level of significance, so we may reject we may reject the null hypothesis at 1% level of significance, and there is a significant difference under null hypothesis. It implies that there is a significant difference under null hypothesis means market A and market B, the food expenditure of women, it is not equal according to the test. Okay, that means there is a significant difference under null hypothesis. It implies that the average daily expenditure of two population of suppers in market A and market B differ significantly. So I think all of you are clear for this particular problem. Hello?
Yes, madam.
Yes, madam.
Very good. Then next we'll come to another example. I think this example, just you read question once. You read this question. Mean wage, it is given for A, 2 plus A and B. Standard deviation of wage, it is given 28 and 40. Number of workers, 1000 and 1500. Level of significance, 5%. All the data it is given to you. Directly, two population size, that means Z test for 2 mean, it will be the formula of Z test for 2 mean, it will be applied. And why it is Z test? Because sample size, it is greater than 30 and it is also greater than 30. For market A, it is 1000, and for market B, for place A, it is 1000, and for place B, it is 1500, which is greater than, much more greater than 30. That's why Larsen test. So here, whatever it is given, just you have to mention here the null hypothesis. So first you have to given the information, then null hypothesis mu1 equal to mu2, because 2 plus information you have to compare it. That's why alternative hypothesis not equal to level of significance 5%, and Z formula, you know, Z formula, because sample mean and sample standard deviation given, and so sample standard deviation given. That's why you, instead of sigma 1 sigma 2, you have to write S1 and S2. Okay, for large sample test, instead of sigma 1 sigma 2, you can use small sample standard deviation, we can use. Okay, that's why you just put the value and get the answer that we have got minus 1.47 modulus, which is 1.47 only. So Z calculated value is 1.47, Z tabulated value is 1.96. So 1.47 is less than 1.96. That means we may accept the null hypothesis, since the calculated value of Z is smaller than the tabulated value of Z at 5% less level of significance. So we may accept the null hypothesis. That means there is no significant difference under null hypothesis. That means whatever the null hypothesis we have taken, there is no difference. mu1 equal to mu2, it is true. So it implies that the mean wage of place A workers will be equal to mean wage of place B workers, because they don't differ significantly. They are equal in wage if you compare. So this problem, I think there is no doubt in this problem. All of you are clear? So today, whatever we are discussing, the same problem you practice yourself. Okay, and if you have any statistics book, fundamental statistics book, you can get the tabulated value directly in the chapter, particular chapter Z test jodi thibo sedi khojibo so paijibo hela. So if you want to solve more problems, you can refer any statistics book, SC Gupta fundamental statistics, you can follow. You get so many questions in the example itself and also in exercise. Okay, so my suggestion, you have to practice more and more questions so that you can understand and how to write the null hypothesis, because for the problem related to testing of hypothesis, null hypothesis, setting of null hypothesis and drawing of conclusion is more important. Okay, so here the same questions I am not discussing, so this one you can do by yourself. Next we'll proceed to another. This one you can do by yourself or not? Step by step problem it is there. You can solve by yourself. Same
Yes,
time. Next we'll proceed to another method. Okay, this is little bit different, so that we'll discuss this particular question. 60 PG economics students are found to have mean weight 63 and 60 inch and 50 MCom students, mean height is this much. Would you conclude that the commerce students are taller than the economic students? So commerce and economic student we have taken, number of size it is given, so taller than it is given. That means what will do now? So N1 it is given 60, N1 means sample size for economics, sample size for MCom, that is N2. So 60 and 50 it is given to you. X1 bar it is given 63.60, X2 bar it is given 69.51, S1 sample standard deviation it is given 2.48 and 2.48 both. For both cases it will be remaining same, it is mentioned. So what is your null hypothesis here? Obviously two group, that's why mu1 equal to mu2. Since it is given taller than that students, it is given means you have to go for Leptel test. Conclude that the commerce students are taller. Commerce student taller means mu2 obviously greater than mu1. That means mu1 is less than mu2, because mu2 we have taken for the commerce and mu1 we have taken for the economics. Since it is given taller than, if it is not mentioned anything, you have to write total test. Means mu1 not equal to mu2. All the problems we have discussed that not equal to, that is total test. But here it is mentioned that whether commerce students are taller than the economic students. That's why we have to put Leptel test. This is a less than means Leptel test or one-tel test. You know that this is not coming under two-tel. If it is not equal to, then it is a two-tel. Since it is given less than means comparison it is coming. That's why it may be either right-tel or left-tel. If it is greater than, then it is right-tel. If it is less than, then it is left-tel. Okay, left-tel test it is coming under one-tel test, not two-tel test. Okay, so level of significance, obviously 5% level of significance. Then Z formula remaining same, x1 bar minus x2 bar. Since sample standard deviation it is given s1 square by n1, s2 square by n2 root over. Then you put the value, get the answer directly. What is the answer? 12.46. So after getting 12.46, that is the calculated value. Here the tabulated value it will be different. For the case of two-tel test, the value is different. For right-tel it is different. For left-tel also different. So for left-tel 5% level of significance, the tabulated value is 1.645. 1.645. But our calculated value is 12.46. So 12.46 is greater than the tabulated value. That's why we may reject the null hypothesis. We may reject the null hypothesis. सेठी से भूल लिखिछि, correction कर दबो हला. किछि किछि जगह रे भूल लिखछि, एटा correction कर दबो आ conclusion टा भी निजे लिख दबो. सेठी काटी देछि, निजे लिख दबो हला. Which is more than or greater than. So it is less than symbol दे देछि भूल रे. That you have to correct it. Okay. So next question. Conclusion निजे लिख दबो, से लिखिनी. Greater than माने we may reject the null hypothesis. ता माने reject the null hypothesis means commerce student reject null hypothesis means accept alternative hypothesis. So what is your alternative hypothesis? That commerce students' height is more than commerce students are taller than the economic students. This statement is true. Okay, only that you have to write. Similarly, another question, this one you can do by yourself. I will proceed further. A question that nije karibo, eta bi same type ro alternative hypothesis greater than achi dekho. Question ne saya देइथिबो तो सही अनुसार एटा प्रॉब्लम सॉल्व करिवो जेंति बुझेली सेंति पूरा सो सब वेराइटी रो दिचाटा क्वेश्चन हेछि तने तुमे प्रैक्टिस एइटु करि सरला परे नेक्स्ट यू कैन प्रोसीड टू रेफर एनी स्टैटिस्टिक्स बुक सो दैट योर फंडामेंटल इट विल बी क्लियर ओके it is very important in research. Those who are interested to do any type of research and conducting any project, all these methods are necessary. You can apply all these tests, okay, for comparison purpose like that. Next one it is coming. पर हमें next method को जिबा. ये सब सेमती चलला, हैला. देखिबो. Next असला T test. T test, हैला. T test. T test similarly T or students T test you can say that. So T test just same whatever you have done for Z test, the T test also remaining same. Only the difference is that in case of T test, you can do that you can check whether the sample size is less or not. If the sample size less, then you can apply t-test. The same method, whatever you have done for z-test, the same method you have to do for t-test also. But z-test when you will apply for sample size if it is greater than 30, and t-test it is less than 30 only. Okay, less than 30, but the method it is remaining same. Just t-test for single mean, t-test for two mean, and pair t-test. सेठी कौन थिला z-test for single mean, z-test for two mean एंती थिला. तो एठी आसला z-test for single mean, t-test for single mean, and the formula for t is सेठी कौन थिला x bar minus mu divided by sigma by root over of n. एठी भी सही same formula, x bar by minus mu sigma by root over of n. सेठी difference कौन थिला सेठी in that case n is your greater than 30, but here n is your less than 30. So for small sample, instead of z-test you can use t-test. Okay. So suppose sigma is not known, then instead of sigma you can use small s also. जमती तुम्हें z test रे करथलो तो एठी हमें small s भी लिख परिबा. तो एठी calculated value तो बाहर कर दबो. Tabulated value सेठी कोन करथले ना directly 1% level of significance, tabulated value is 2.58. 5% level of significance, the tabulated value is 1.96. So like that way you have to it must be given to you. Similarly, here also, any statistics book you follow, that back side you'll get t table. T table you'll get. Okay. By using t table, जे कौन सी statistics book रो पछाड़े देखिबो t table थिबो, f table थिबो, chi-square table थिबो. तो किंतु z table ता न थाय. Z table रो value ता भितरे देई थाय. जोठी whatever wherever it is discussed for z test, the tabulated value it must be given in that tabular form in chapter itself. But t table, f table, and chi-square table tabulated value it is given in the back side of any statistics book. You'll get that one. But how to check for the how to get the t table data, tabulated t value? We have to check for the 5% level of significance, n minus 1 degrees of freedom. So what is your n? N is your sample size. So sample size, suppose it is 50, suppose it is small sample, no? Suppose it is 20, then 19 degrees of freedom, you check from the 5% level of significance, what is the tabulated value? It is given in the table, directly you will get. Or in the exam, they will provide you the t table or f table or chi-square table, so that you can get the tabulated value. So now I'll show you also in the next class. I'll show you how to get that one. And the net also, Google, you can search for the t table, how to get that. You get that one. Only degrees of freedom, that suppose 19 degrees of freedom, this side you check row, and 5% the upper side, 5% means 0.05. You'll get the tabulated value directly. Okay. So here the question, just we will solve one question. A random sample of size 20 from a normal population gives a sample mean of 42 and sample standard deviation is 6. Test the hypothesis that the population mean is 44. State clearly the alternative hypothesis that you allow for the level of significance 5% you have to take. So sample size, what it is given 20, but in that case it may be 200, it may be 1000, like that. Here it is 20 means less than 30, and the sample mean single mean it is given. Single sample mean it is given 42, single sample standard deviation it is given 6, and population single mean it is given 44. So directly t-test you can apply. Same, whatever it is given. First you have to write the given information. X bar is equal to sample mean 42, sample size 20, okay, sample standard deviation 6, and population mean it is 44. Then null hypothesis mu is equal to 44. Okay, that you have to take. Then alternative hypothesis not equal to level of significance 5%. Test statistics t is equal to x bar minus mu. Since the standard deviation, population standard deviation is not given, that's why you have to take sample standard deviation divided by root over of n minus 1. So you will get minus 1.45, and the modulus value of 1.45 minus 1.45 is 1.45. Now you have to compare that calculated value and tabulated value. So calculated value of t is 1.45, tabulated value at 5% level of significance with 19 degrees of freedom is 2.093, which is less than that one. So calculated value is less than the tabulated value. Okay, eta niche check karibo, je kono statistics book you follow, you will get the backside t table, then you will get a degrees of freedom that is your degrees of freedom 19, because 20 number of sample data. So n minus 1 degrees of freedom. That's why 19 degrees of freedom in row, and column 0.05 means 5%. You'll get 2.093, which is less than that. Means calculated value is less than the tabulated value. So we may reject, not reject, we may accept the null hypothesis. And you have to write the conclusion like this way. Since the calculated value of T is less than the tabulated value of T with 5% level of significance at 90 degrees of freedom, so there is no significant difference under null hypothesis, and the null hypothesis is insignificant. That means mu is equal to 44 is true statement. Means whatever the population mean we have taken, that is 44, it is correct. Okay, or it is true. So I think all of you are getting the meaning of t-test and z-test for single mean, for two mean, and t-test for single mean. So I think all of you are clear. Any more doubt from this problem?
No, ma'am.
Very good. The next problem, today we'll discuss this second problem, then we'll stop it. I think here instead of mean, sample mean, directly the data it is given. Directly data it is given. A salesman is expected to affect an average sales of this. It is given, means a sample test derived from the particular salesman had made the following sales data deidala rupees. Okay, but the population mean it is given 3500 rupees, 3500 it is given. That means population mean means mu it must be given to you, that is 3500. But sample mean it is not given, sample standard deviation it not given. Directly you can find sample mean and sample standard deviation by using formula. You know that how to calculate sample mean, how to calculate the mean and standard deviation. The formula x bar equal to summation x by n. It's small n hobo. Okay, small n means sample size. What is the sample size? 6. And sample mean you will get 3300 sample mean, and sample standard deviation summation x minus x bar whole square divided by small n, or you can write this formula summation x square by n minus x bar square root over any formula you can use, and so that we are getting sample standard deviation, that is 1016.53. Then sample size is given 6. So x bar is given, sample size is given, s is given, mu is given. Actually x bar and s it was not given, you have to calculate. Data is given. So mu is equal to 3500, that is your null hypothesis. Already I told you have to take only for the population mean, population parameter, the only mu, that is your 3500. So what you have to check, if it is not mentioned anything, you have to take not equal to or greater than or less than. Okay, or not equal to also you can take. So level of significance 5%, t-test it is x bar minus mu small s by root over of n minus 1. One thing you have to remember, if you use capital sigma, then it will be root over of n. If you use small s, then you have to use n minus 1, root over of n minus 1. Means sample standard deviation, if sample standard deviation is given or it is obtained, then the formula will be changed, means root over of n minus 1. If population standard deviation is there, sigma, then it will be root over of n. Okay, so like this way you'll get the result, that is 0.4399. 0.4399. T calculated value is 0.4399. T tabulated value is 2.015. Why? Because 5% level of significance. What is your n here? 6. 6 minus 1 means 5 degrees of freedom. 5 degrees of freedom, 5% level of significance. T tabulated value is 2.015. From the T table you'll get. If you have the book, just you check for the T table and you check that 5 degrees of freedom in row, in column you check 0.05, and the value you'll get 2.015 or not. Just to check, you can get that it will be 2.015. And now you compare 0.4399 is less than 2.015. That means we may accept the null hypothesis. So there is no significant difference under null hypothesis. Whatever the mu you have taken, that 3500 is the population is the population mean, that is the average sales of the company or whatever, it is rupees 3500. Okay, true. It is a true statements. So like this way, today we have discussed Z test we have completed, and T test for single mean we have completed. And my request is that please you solve more and more problems related to that, or then only you can understand. And if it will come in the exam, how to differentiate Z test and T test, I think you can get Z test for single mean or Z test for two means it is more than the sample size is more than 30. If it is less than 30 means you can use T test. So how to solve the problems and how to get different type of problem we have discussed. And next class will complete T test, and next whatever it is there will complete it. So like that way, please you practice more and more questions, and if any more doubt you can ask me. I am giving you 2-3 minutes, please. जदि कहार किसी डाउट अछि पचारो. Hello. Hello.
Yes, ma'am.
किसी डाउट अछि जदि पचारो.
No, ma'am. No.
Very good. So now you may leave.
Yes, ma'am.
Okay.
Thank you.
So next class I think Saturday, no?
Yes, ma'am.
Okay. So next class same time we'll discuss more. That whatever we have discussed today, please you practice yourself. If any more doubt, next class you may ask the question. Okay. And PPT, I think all of you have got PPT also.
Yes,
All of
ma'am.
you.
Yes, ma'am.
अरे PPT पाइছো कि नहीं?
Yes, ma'am.
Okay. अरे डा मोर केमती ये कहला एटा मते शो करूनी सेटा पूरा टॉप रे रहिछि से लाइन टा सेटा मु केमती पूरा देखिबी कहला ए जो जूम रो खाली टॉप रे मते देखा जाउछि आ एटा मते देखा जाउनी मु केमती ये करबी क्लिक कर देबी सेठी
वो फ्रीज है जाइछ मैडम.
ताले बंद कर देबी.
हां बंद करना. क्लोज विंडोज क्लोज कर दियंत.
ना विंडोज तो क्लोज मु कर परनी एटा केमती कोन मोर बंद होनी काई के ठीक अछि.